Hello guys, you're welcome to the second video in this series. And in the last video, I showed you guys a showcase. Gave you a showcase of what we're gonna be making throughout this video series. And so in this video, we're gonna start making those stuff. And right now, I want to show you the library and the requirements. You need to have some requirements ready before you can start developing. And the first thing you need is the Allegro 5 library. Okay, this is what we're going to be using to create our game. This is the framework that's going to be used to get handles for the display, the keyboard, the mouse, the joystick, and all those things we're going to be using in our game. Okay, and it's a very fast and beautiful, easy to use library, and it's cross-platform, which means you can use it on Windows, Linux, Mac, iPhone, and Android. So if you write your program once, you don't have to modify it too much to work on all these platforms basically. And like I said, it's easy to use, it's fast, and yeah. Another thing is, if you want to compile, if you want to get this library, okay, just go to this website right here, the GitHub page for Allegro 5, and read the instructions on how to get the Allegro 5 library. Okay, you need to read the requirements and how to compile or build it. Okay, it's not too difficult. If you're on Windows, you don't have to compile it yourself. You're gonna have to just maybe download one of these pre-built binary files, and then you can use it. Okay. So if you're on Linux, you can either use a package manager, or you just build the project from source yourself, build library from source yourself. Okay. So once you have Allegro 5 library set up, we're gonna go straight to the IDE of choice. Okay, the development environment. Now, if you don't want to use an IDE, you want to use a text editor or command line or stuff, it's fine by me. But I'm going to be using an IDE because I think it makes my work very easy. So GCPP is going to do that. I'm going to use GCPP. I found that this IDE is very fast and lightweight, so and it works quite well for almost everything I do. Okay, and so that's why I'm sticking with GCPP right here. So if you wanna use it, you can just come straight here and read instructions on how to compile it for your platform. Okay. Another thing is, although you can use whatever ID you want, like I said, you don't have to use whatever I use. You can use whatever ID you want. And with that said, let's get started. Okay, so right now I'm going to be using the GCPP IDE, like I said, C++ or whatever you want to call it. So I'm going to click on File, New Project, C++, basically. And whether I want to save it, I'm going to save it as sugar, just like that. And I'm going to click Create. Okay. So what this does is it creates a couple of things right here for me. I have a client format, symmetric text, and main.cpp. So it uses CMake. So if your build system is CMake, you can easily follow along with this tutorial. Just copy whatever is here and put it in your CMake list of text. Or you can just build a project whichever way you can. Just make sure that you link and compile the libraries whichever the proper way, okay, so that everything is going to compile and run properly. So the next thing I want to do is okay. GCPP does something very annoying. It sets my indentation tab to 2, so I like to change that to 4. Okay, basically for all of my projects, it changes to 2, so I like to use 4. With that said, let's go back to our main.cpp and let's start initializing stuff. Okay, I have to do that for this one too. So this is 4, beautiful. Now. So I'm going to include a couple of things here. I will do 5. Before I get started though, I want to quickly do something. Sorry, because I like to forget this stuff and I get errors. Pretty much, so I'm going to call out here first. So what I'm doing here is I'm actually linking the Allegro library. Okay. So we have this thing called add-ons for Allegro. This is the main library for Allegro 5. Okay, And we also have some add-on libraries like the Allegro font, which enables us to use fonts in Allegro file. Allegro, when we start using those things, we're gonna get to those in a minute. Okay, so I'm just gonna include Allegro file like this, and then type right here. Good. If not, it'll init. Just gonna return 0. It helps if you just want to print an error message here, okay, before you return, but I'm not going to do that because I'm too lazy, okay? So print error message before you return something, and I'm not supposed to return 0 or something like that. Just want to just see it as an error. So what this means is if Allegro is not successfully initialized, then you want to quit the program. There's no need to do anything, okay? I'm going to create a couple of things here, which I'm going to explain in a minute. Cool. Now let's see. Excuse me. By 60. Nice. So the next thing we do here, register and source. I'll get display and source. That's the display. Register and source. Thank you. I'll get timeline and source. I want to use keyboard, so I'm going to have to come down here and do keyboard. Nice. Next, register and source. Then source. And the next thing we do here is we do first file. So right here, this is our menu. Right here. Then close, so we want to display this event right here. If that happens, say equals false, and then I go event let's just time first. I'll go event time. Okay, so quickly I'm gonna come back up here and define some methods. Cool. So here, update and I think I should call handle input before update. Okay, so we can handle our input before we do the updating of our main objects. Good. Alright. And then we said, oh, nope, we're not gonna render here. We're gonna set withdraw true. Now, if we draw, error is then t, that's the event here, and then we say draw plus pretty much, yeah. I think that's it for this one. And this is the end of our while loop. So I'm gonna call this code right there. The functions will be at the top. Update. So we put those ones here. Go ahead and enter. Cool. And let's quickly dispose of all these things before I start explaining what I'm doing here. Destroy display, destroy timer, destroy queue, right there. Good. And I made I think there's a mistake. Oh, fine. I'm just gonna take these two, put them out here, and put them out here, I guess. Yeah, that works fine. Yeah. Okay. The next thing we're gonna do now is come down to our render, and then I'm doing all these things so I don't forget. Page or whatever. So right here, we're gonna do player screen. Object here. Alright, cool. Clear to color map RGB. So we're gonna use RGBF. We're gonna use 0, just any color, I don't care. Cool. And I think that is it. Okay. Let me quickly run this and make sure everything is working before I explain what I'm doing. Oh, it looks like everything is working. So cool. So now let me quickly run down what I'm doing right here. Okay. So the first thing I'm doing here is I'm including a string which I obviously haven't even used yet. And then I'm including the Allegro 5 header. Excuse me. I'm including the Allegro 5 header right here. And then I have 4 function definitions: update, render, handle, input, dispose. And then I'm creating 3, let me quickly explain what all these functions will do. The update will update the states of whatever objects we have in our game. So if say like we have a car that's going to move from here to here, so update is going to help us do the calculation and translation and those things. Render will help us draw those things on the screen. Handle input will help us handle whatever input we get from the user. So maybe somebody, the player playing the game, we're going to get input. So this function is going to handle whatever input the player passes to us, okay, or gives to the game. And dispose is going to clean up all the allocated stuff when we're done. Okay, cool. So the next thing we have are pointers here. This one is a pointer to an Allegro display. An Allegro display is let me show you. An Allegro display is what you see right here. Okay, you see shoot again at the top right here, and this window here is called a display. Okay, so if you think of this as a window, then this is a display. Okay, and that's what an Allegro display. So it represents our display on the screen. Okay, the next one is the event queue. And the event queue is simply a data structure that holds events. Okay, so when some objects in our game generates events, it's going to be put in an event queue so that we can handle and respond to those events. The timer is simply a timer, just like a normal countdown timer. Okay, and all the timer does is generate events. Okay, so I'm going to explain what that is in a minute. The next one we have here is our, of course, main function. This is the entry point of our application. This one, if not AL limits, return -1. I already said it here, we're initializing Allegro 5, and if we're not able to initialize the core library, then we're basically returning -1 to say, hey, this program terminates incorrectly or something like that. Sorry, this program terminates incorrectly. Okay, so that's what that does. And then we have here display equals create display. So remember when I said we have our display, our window. This is where we create the window right here. Okay, we create the display, and I give you the dimension of 400 by 400. So if you look at it, this is it. Okay, 400 in width and 400 in height. So that's what the 400 and 400 is right here. Now event queue, AL create event queue. So we create our event queue right here. Remember all these are pointers. I'm sure you know what pointers are. Okay, so all these are pointers to this object, right? So and then we have a timer. Okay, so we create our timer and we have 1.0 divided by 60 as a parameter. So what is this 1.0 divided by 60? Um, Simply, the timer takes in a speed per second. Okay, so basically, if we have a timer of like, if I had passed in something like 2 right here, for example, then the timer is going to fire, it's going to generate events every 2 seconds. Okay, so what we want to do is for this timer to generate events every 1/60th of a second. Okay, so 1/60, which is be I think 0.01667 or something. Yeah, seeing millimeter with something, I'm not sure. Meters per second, sorry. So, milliseconds. Sorry, excuse me. So this is going to generate 0.01667 milliseconds, I guess. Everything. Anyways, so basically we're using this timer for our game loop, okay, and we want this timer to fire every 60 times every second. Okay, so we want to generate events 60 times every second, and for each time it generates an event, we're gonna do these three things. Okay, we're gonna handle input, update, and then we're gonna render our screen. But we'll get to that in a minute. So we create our timer here. We said it's gonna fire every 1/60th of a second, basically 60 times a second. Let me put that as the comment. Fire 60 times every second, right there. Okay. And the next thing we do is we initialize our keyboard using the install keyboard. Then we register events. So remember when I said event queue holds events. Okay. So anything can generate events. Anything you register with the event queue will generate events, and the events will get put inside the event queue. Okay. So you have to register an event source. You have to register the objects to generate events inside the event queue. So for example, my display will generate events. So I'm going to use the AL register event source to generate to tell my event queue that okay, whatever events the display generates, please store them for me. Okay, I want to handle those things. But I also tell the event queue. I also want to handle events generated by the timer and events generated by the keyboard. Okay, so when a user hits a key on the screen, sorry, excuse me, when a user hits a key on the keyboard, the event is going to be generated and you put in this event queue. When the user, when the timer ticks, the event is going to be put in the event queue. And when a display generates an event, it's going to be put in the event queue. So that's it. The running is for our game loop, and we withdraw our screen in a minute. So here we start our timer. We say the timer should start running, and then we say while our game is running, we create an Allegro event right here. So this is the events that get put in the event queue. This is where we use to take the event out of the event queue and take care of it right here. So we create an Allegro event and we wait for an event to happen. So basically, this is going to block and say, hey, I'm waiting for something to happen. I'm waiting for somebody to generate an event and put it in here. So when that happens, the event gets put in the event queue and the event object gets populated. So this one allows us to query what kind of events just occurred and to respond to it, like that. So here we have a switch statement that tries to determine what kind of event that was generated. So if a display close event was generated, then we're going to set running to be false. So it means the user has requested for our display to close, and so we're going to stop running our game. The next one is a timer event. Okay, so if the timer has fired, remember the timer runs 60 times every second. If it fires once, then we're going to update, handle input, and of course withdraw. So we said we draw the true right here, and then so instead of having render, we just said we draw to be true. Why do we do that? Well, if we don't want to draw anything on the screen yet until we have made sure that our event queue is empty. Okay, so if our event queue is empty, then we want to draw. So basically what we did here is we said if we draw and event queue is empty, then we want to render something, and we reset our withdraw to make sure that we can use that. Okay, cool. So if our event queue, there are still some events to be processed in our event queue, then we're not going to draw anything. We don't want to have like old updates. We don't want everything to be synchronized in our game. So that's why we do this. Okay. Yeah. And at the end of the day, once our game loop closes, we call this post. Okay, so which means deallocate all the allocated objects and all the created stuff right there. So you see this post just destroys the display, timer, and event queue. Okay, so whenever you create your own programs, make sure you call your destroy display, your destroy timer, and your destroy event queue to free the memory taken by all these three objects. Cool. And then you file our render function. Inside our render function, we're not doing much. We're just clearing the screen to a color, and then we're flipping our display. So basically, this one says clear color means clear the screen with this color right here. So this takes an Allegro color. So if I hover over this, you see type Allegro color right here. So this Allegro color is what returns. So mapper RGBF returns an Allegro color object that gets put inside here, and that's what they use to clear the screen. Now, if you draw anything on Allegro 5, if you draw anything, it's going to be drawn to the back buffer, okay? Until you call it a flip display, you see that stuff on the screen. And yeah, I think that's that. And so if I run this again, you see that it's actually quite easy to uh, it's quite easy to create a window in Allegro 5 if you get the hang of it. Okay, you just have to read and reread the source code more than once if you don't understand. And I'm sure it's going to make sense to you after a couple of maybe videos. Okay, so if you don't understand, just try to watch the video again. Take it step by step, very basic. Make sure you read the documentation of the Allegro 5 library. They'll clarify lots of things for you. And if you have any questions, you can post it in the comments below, and I'll be sure to help you out. With that, see you guys in the next video.